Let's see what's new on the Monster Mill.
Hey, I am very excited to share something with you. Now, I've been working on this for about 3 or 4 weeks, and I started off doing some stuff with the 5-axis mill for Monster, and I quickly realized that measurements are really important when you get more axes involved, and to get things set up properly, you should really have a touch probe so that you can zero things very, very accurately. So I kind of put that on a little bit of a pause and jumped into the probe stuff. And because I was going to write some new routines, I didn't want to use my expensive probe. So I found one online, and we'll get into that a little bit later. So my friend Marshall 3D printed it for me, and I used it to develop a bunch of routines. But this time what I did was, instead of just making simple routines that I could put into my little PYVCP panel, I decided I was going to use Glade. And the interesting thing about Glade is you can incorporate it into the center screen of Linux CNC. And I made it so that you don't have to start with a raw machine and develop it from the ground up. You can take your machine, add my code to it, and then you'll have all this functionality. So right now it looks like I'm going to do a 3-part video series on this, or at least a 3-part video series. The first one is this one, where I'm going to just introduce you to what I've done. Then number 2, we'll go out in the shop, and if I get a chance, I'll video some of that tomorrow and demonstrate a few of the routines and so forth. And then I'm going to make the 3rd part, basically a sister video, which is going to go through all the step-by-step of how you can take the files and add them to your machine. And I'll end up putting the files up on the internet on my server and giving you a link in the description when I get them posted. So tonight I'm sending the routine and the beta file on how to install it to a friend of mine, Max, in Kentucky, and he's going to try adding it to his machines. And if he encounters any problems, he's going to let me know. And then once we verify that, yeah, it can work and it can be done, and it should, because I've already done it on another bogus machine that I created here, you will have all of the routines that I wrote. And I'm very excited to share that because I really put a lot of thought into it, and I think they're very useful. And the nice thing about this whole community is if you guys come up with an idea, or you guys come up with a routine or something that's like really great, I can incorporate it into mine and then push out another video that shows how to add those features. And that way we as a community can have machines that are just doing stuff that nobody else's machine can do. And I think that's cool. Anyway, I'm going to stop yakking right now, and I'm going to switch it over to a little PowerPoint that I made to kind of go through and show you what I've done. So let's do it. So let's take a look at what the embedded probe routines that we've got are and kind of go through them rather quickly here. Okay? So this is what your screen would normally look like. But if you'll notice, up at the top where the tabs are, there's now a new button, and this is what we're going to learn how to add. So what does this new button do for us? Well, let's take a look. It's going to add a whole lot of new functionality to the machine. I've spent the last 4 weeks designing this and adding these functions in, and I've made it so that it's easy for you to add them into your machine as well. So I'm going to go through them really quickly, and then there'll be other videos which have more detail. First off, I want you to notice that we've got a whole bunch of tabs. Once you click on this, it adds many new features. Then let's go through them. So the first one is called a PEC drill cycle. When you're going to drill, let's say, a piece of metal, one of the things that you don't ever want to do is to take your drill press and then just mash down on it, because of 2 things. It's going to cause the bit to overheat, and you're going to get these long metal streamers which are going to come out, long piece of swarf, and it's going to wrap around things and so forth. So what you want it to do is you want it to go down a little bit and then come up to break the chip, down a little bit and come up to break the chip. So now you don't have to write G-code. Just move this where you want it, tell it how deep, what the increments for the PEC are, what the feed rate is and what the speedometer, the RPM is, and hit the button, and you're good to go. It will automatically go ahead and do this for you. All right. So then, once I got that routine built up, the next step is this guy over here, a bolt hole circle. So I know you've seen something like a pipe flange that has multiple holes around it. Guess what? You don't even need G-code. You come in, you tell it the number of holes that you want, the radius off the center, the depth for each peck, the speed, and the spindle speed, and you hit the button. And it will go ahead and it will make all the holes for you at the right depth and everything without a single bit of G-code being needed. And the routine really works well. I've used it several times already. The next thing is up here. You'll notice a bunch of buttons. Yeah, if you've been using Linux CNC, you know you have to go over, you click X, you move it around, click Y, you move it around, and it can be a little bit of a pain. So I've put a little dashboard right here. You can just sit there and click on your X, Y, and Z and move it around, and you've got one little jog slider there, which will change the speed. You'll probably find it very useful. One thing I did notice, though, is sometimes the first time you use it, there's like a little bit of delay. It's something to do with Linux CNC, but you'll see what I mean. You'll figure it out, but still very useful. Then underneath of that, I've got a few things. We'll start at the bottom. There's an idle busy and there's an active LED. So that's going to tell you that the active one is going to tell you whether your machine is activated or not. So if you look up in the upper left hand corner, you see that the power button is depressed. That means the machine's active, it's all ready to go. That's just a little indication of that. And when you're actually running a program, the other buttons will become unresponsive because it's only going to do one at a time. So that idle busy will tell you, hey, no, I'm busy doing something else, I'll get back to you. And I found it very handy as a good visual indication. Alright, now let's jump into some of the probe routines. What I did was I tried to figure out the ones that I use all the time, and I made routines for each one. So let's take the first one here, the left rear. So say that you've got a vise, and you're going to use that vise and hold a piece of stock. And in your drawing, that left rear corner is the 0 point. Well, what you can do is bring the probe just over the top of that corner, press this button, it'll go down, find the surface, go off to one side, go off to the other side, compensate for the diameter of the probe, and it will set it exactly on that corner. That's going to save you a lot of time. The next one over is if you have an object, you can find the left, right, top, and bottom of it, and then what it's going to do is it's going to put the tip right in the center. So if your model has the design, the 0 point is in the center, it will help you find that. The next one over to the right is for holes. So say you've got a 1/2 inch 20 millimeter hole, whatever, and you want to make it bigger and you want to do it accurately. You put your probe into the hole slightly, you click that button, it's going to very accurately find the center for you. And it's going to set that as the new XYZ center so that right from there you change your bit, you set your height, and you're good to go. The other ones are different corners, one for just measuring the width only, the length only, and the right front corner. So again, very useful routines. I've been testing each one out. They all seem very stable. I'll get feedback from y'all, and if any of them need to be tweaked, I'll tweak it and put it out in a later release. Then I've got some more for when you just want a single side. You want to know where the front, the back, left, or right are. You want to know what the surface is. These are very simple probe routines. The next one, there's going to be 3 routines. Right now, as I record this, only the first one is written. So say you make a jig or you mount your part to your mill, but you don't have it exactly 90 degrees. You don't have it lined up exactly 0 on the front. And you go to machine it, your stuff can be off. So what this will do is it will go to the front surface and it will take 2 readings 150 millimeters apart. Then it will determine the angle and it will actually change your coordinate system so that as you move your X and Y around, it will be compensated by that angle. And this is going to be very useful. The next one, the fixture alignment, and I hope to get that routine added in very soon, is a custom fixture that I came up with where I've got two 20mm holes spaced 100mm apart. So I can take a jig, drop it in there, and zero it all out and do a job. And then put the jig on the shelf, and then maybe next year or the year after, if I have to make some more of those parts, I just drop it on my mill, line the probe up with the first hole, and it will automatically compensate everything so that all I have to do is run the job, and the job will come out perfect every time. The last one, I don't know. I had space for 3. I put 3 up there. I've got a few ideas. We'll see what happens. Now, these are the settings. So if you're going to do a hole and you're going to be going back and forth and so forth, obviously if you were close to, let's say, the left edge of your machine and we told it to probe 500mm, it's going to just come up and tell you, hey, I can't go that far, and the routine's going to stop. That top slider will allow you to adjust how far off center it's going to search for the walls of the hole. And then the one here in the middle is used for anything that does any width, any height, or the routine that does all 4 sides. And so you can independently tell it how far to search for your X and Y. So say you've got something that's about 100mm wide and about 50mm tall, you can tell it, hey, I want you to search 150 on either side, or 75 on either side, and that way you're doing a good search. You're not going to crash into it on the way down. And by the way, the vertical movements use a probe, so if it does hit, it just stops and says, hey, I hit something, and it'll return to you the length, the width, and it'll put the bit in the center and zero it there. And then the last one is just for your vertical probing. How far do you want it to search downward? Now, probes. You can get probes with different size tips. I'm using one that was pulled off of Thingiverse, and I'll go on to that in a little bit. And the probe tip that I have is actually nothing more than an M5 bolt, and that happens to be the diameter of the cap head on the bolt that I'm using. The nice thing about this is whatever probe you have, you can enter the probe tip diameter in here, and all of the routines will compensate for that properly. The bottom is just a test routine. If you want to make sure the panel's working properly, you can just hit that, and it's just going to return a couple of message boxes to let you know, yes, everything's working cool. And then the last one is a calculator. Why? Because I could, and I figured it might be very useful, so I put it in there. So what else do we have? Thingiverse, thing number 721620. It's a touch probe by Scorch, and he was very gracious to allow me to use his information in here and so forth. And his web page is really great. He's got a lot of good details. The probe is fabulous, especially when testing routines. I didn't want to take a $200 probe and risk cracking it into something, so this was easily 3D printed. And so if you go to Thingiverse, you're going to come to his page here. He's got all the model data that you need to 3D print your own. I made a couple of little modifications. He's got a little plastic thing coming out the top where it goes into your collet. I modified it slightly to where I've got a M5 bolt coming through there, and that way it fits into my collet a little bit firmer. I like that a little bit better. And his probe is a point. Well, I made mine where the center is threaded, so I can thread a pointed one in, or I could thread in an M5 bolt, or I could go buy a professional jeweled, like ruby tip or sapphire tip, and use it. So very good probe page. I've got it bookmarked, and it's one of my favorites. Not only that, but he's got some really great software called G-Code Ripper. And you can take a probe and probe out an area. In this case, he probed out the surface of a mouse, takes his artwork, and it tweaks it so that now it is bent and shaped to fit the object, which means that when you mill it, it will fit on there perfectly. And if you're doing circuit boards, it's really great because you can look at the surface of the circuit board material, and you can make your thing fit it. And a lot of times you'll think that a circuit board material is flat. It's never quite flat. So very, very useful. So stay tuned for more. We've got a lot of cool things coming up, and I'm very excited to share them with you. Thank you.